Scatter plots, correlation, and fitted lines. Our objective for this lesson, I can create a line of fit to data that shows a linear correlation and use it to make predictions. So first we have a little vocabulary to talk about. Bivariate data. So this is the word bivariate. Bi meaning two. Bicycle, two cycles. Bi meaning two. So bivariate data are paired values of two variables. And what we mean by variables here are changing, meaning they vary, changing values. We don't necessarily mean like X and Y as a variable, okay? Yes, that is how we use that word, but here we're meaning, so basically bivariate data are paired values of two variables, such as a person and their eye color, bivariate data, person to eye color, okay? Also, anything that compare the day and the average temperature for that day, okay? So that's bivariate data, okay? So basically, it's got data that has two parts to it, okay? And scatter plots are graphs of bivariate data. Since bivariate data has two variables, we'll graph it on an axis with two axes. One axis will be one of the variables. So you'll have one variable on one of the axes, such as the day of the week, and then the number of hours in school. The other variable will be on the other axis. Create a scatter plot. So the measure of the direction, which way the data is going, and the strength of the linear relationship is called correlation. So we talk about the correlation of the data. We're talking about which way is it going and how strong does it go that way. Basically, how well do the two relate to each other? And we'll talk about this strength idea later. Right now, we're mainly going to talk about direction. Okay. So in a scatter plot, you can observe whether there appears to be a correlation between two variables and what type of correlation there is. So if we notice in this first graph, as this variable gets bigger, this variable tends to get smaller because they tend to trend down. This is what we call a negative correlation. Because as one variable increases, the other decreases. Okay. Or if I was to kind of connect a line into here, it would have a negative slope. Okay. It's going down from left to right. So we call that a negative correlation. So as you may have already guessed, one that goes up from left to right, we call a positive correlation. Okay. So positive correlation is as one variable increases, so does the other. So does the other. Okay. Hey, or we may have a situation like this one where they're kind of all over the place. It is possible to have no correlation at all. So bivariate data usually either has a negative correlation, a positive correlation, or no correlation at all. Okay. All right, so now we're going to look at some data. Hattie sells hot cocoa at a farmer's market. She believes that people tend to buy more hot cocoa as the weather gets colder. The table shows data for the average daily air temperature and the corresponding number of cups of hot cocoa sold. Okay. So if we notice here, so this is the average daily temperature. So the average temperature for that day was 30 degrees. She sold 300 cups. 42 degrees, 265 cups, so forth and so on. The air temperatures are shown in increasing order. So if you notice, 30, it keeps getting bigger all the way up to a hot day of 98. What do you notice about the number of cups of hot cocoa sold as the air temp increases? So as this air temp goes up, what happens to these numbers over here? Well, it looks like they go down. So what do you notice about the number of cups of hot cocoa sold? The number of cups sold decreases. So that tells me this is a negative correlation, because as these go up, these over here go down. I shouldn't mark that all up. All right. So now we want to make a scatter plot of the data. Does the scatter plot support your answer to part A? What type of correlation do these data have? Now, I thought I had graph paper in here. If you have graph paper, you can go ahead. I'm just going to go ahead and grab a piece of graph paper. There we are. Okay, and I'm going to go ahead and graph this. So I'm going to put the temperature on my x-axis. So here we're only dealing with positive temp. I'm going to give myself lots of room. And positive number of cups. So I really only need the first axis, the first quadrant here, positive and positive. I'm going to put temperature in degrees Fahrenheit on this side, so you got to make sure your label. And then over on my vertical axis is going to be the cups sold. Okay, so now I have to decide on a scale. So if we go back and look here at the data, it looks like my temperature goes from 30 to 98. So I think maybe counting by tens. So we'll mark this as 10, 20, 30, 50, 60, 70. I'm just going 82 so it doesn't get too crowded. 110. We really don't get any higher than that. Or we'd probably have room. We probably have room to go by fives just because I have room. So let's go ahead and let's adjust that. 5, 10, 20, 25. This would be 30, 35, 40, 50, and 60, 65, 70, 75, 80, 85, 90, 95, 100. Because my temp only goes up to a maximum of 98. So I can go from 30 to 98. Okay. But now my cups hold. I need to go all the way to 300, but all the way down to 25. So we need to decide on a scale here. So let's go ahead and let's try to, if I go by tens, would I have enough room? 10, 20, 30, 40, 50, 60, 70, 80, 91, 10, 20, 30, 40, 50, 60, 70, 80, 92. Nope, I need to go to 300. So maybe go by 200s. 200. So this would be, wait, not 200s, 20s. 20, 40, 60, 80, there'd be 100. 20, 40, 60, 80, 100, 120, 140, 160, 180. Something's not looking right. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Yeah, we're good. 220, 240, 260, 280, 300. All right, so there, I think we've got it. So now let's put our points in. The first one is the point 3,300. So 30, 3,300 puts me there. Then we have the point 42, so a little past 42 and 265, which would be about there. Okay. And then we have the point 45 and 250, about here. Oh. Okay. And then we have the point 46 and 225. 225 would be right about there. I'm going by 20s there. Then 58. It'd be almost to 60, and 192 would be almost 200. Okay, and then we have 62 and 150 be right about here. There's 140, so 150 be right about there. For 62, 70 and 75. 60, 80, so 75 would be there in the middle. 77, so a little past 75 and 45. Again, keeping track of our scale, there's 20, 45 would be in between 45 and 60. That might have been a little high. 85 and 40. 95 and 30, and then 98, almost to 125. Okay, there's my points. Dot, 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 dot. I'm sorry, my pen kept wanting to like jump around. So, does your scatter plot support your answer to part A? Sure does. As we go over, my graph goes down. So that does show that negative correlation. What kind of correlation does this data have? We already answered it. Negative. It has that negative correlation. Okay. All right. So characterizing a correlation as positive or negative indicates the direction, okay, of the linear relationship. To indicate the strength of the linear relationship, you can use words like weak and strong. Okay. So you use words like weak and strong. Basically, a strong correlation, all the points are going to be really close to all being on the same line. So here we have some different types of correlation. If you notice, both of these are positive. Graphs 1 and 2 are both positive. They go up from left to right. They're positive correlation. As x gets bigger, so does y. But if you notice, these points are all really close to this line in the middle, whereas these ones are farther away. So we say this first one has a weak positive correlation, whereas this one has a stronger positive correlation. Okay. So we use the weak or strong to talk about like how the strength of basically how close are the points to all being on one line. A super strong, the strongest correlation you can have is one where all of your points are exactly on the line. Is the strongest correlation you can have. And once we learn in the next section, we'll know how to, we can describe it better than just weak or strong. We'll actually put a number value to it. Okay. So now in graphs 3 and 4, both of these have negative correlations, but again, this one, all the points are really close to the line. This one, they're farther away. So this first one has a weak negative correlation, and this other one has a strong negative correlation. Okay. So here we are going to start talking about giving that correlation coefficient, which is basically a number value. Okay, is the correlation coefficient is the number value used to describe its strength. Okay. And it's also used to describe its direction. We denote it by normally the letter R. In R, your correlation coefficient is always going to be in between -1 and 1. And it's a statistic that describes how closely, okay, the points in a scatter plot cluster about a line. Okay. So if my correlation coefficient is exactly 1, I'm going to have something like this. The 1 that it's positive tells me it's positive correlation. So the positive 1 is going to be positive correlation. The negative 1 is going to be negative correlation. So it gives you that direction. And the closer it is to 1, the better the fit, the closer the points are to the line. So here in my weak one, this might have a correlation coefficient of positive 0.8. Okay. Whereas this one with the stronger causative correlation might have one of 0.98. Okay. They're both positive because it's positive correlation. And this one is closer to 1 than this one is, which tells me it's stronger. Okay. Whereas this graph 3 might have a correlation coefficient of negative 0.79. Okay. And this graph 4 would be negative 0.92. Okay. So you can tell that these are both negative correlation, and this one is much stronger than this one because it's got a better It's closer to that -1. Whereas a no correlation, like if we looked at a graph of no correlation, this one might have a correlation coefficient of like 0.05, really close to 0. If it's close to 0, it doesn't really have, there's really no correlation there at all. Sorry. Okay. Okay, so we've already talked about this a little bit. Use information in tasks 2 and 3 to answer the questions. Which of the graphs displayed, so up here, graph 1, 2, 3, or 4, is going to have an R that is close to -1? Well, that's going to be graph 4. Because it's a strong correlation and it's negative. What about an R close to 1? Well, that's going to be graph 2. Because it's a positive correlation and it's pretty strong. An R in between 0 and -1, well, that's going to be graph 3. And then the R between 0 and 1 is going to be graph 1. Okay, we've already talked about that. So estimate the correlation coefficient that describes the hot cocoa data in task 2. So if we go ahead and look at this, well, first of all, you might be like, we don't have a line. Go ahead and draw a line in. Let's draw a line in. I'm going to eyeball it. And I want to be as close to as many points as possible. So I could put it up here, but then it's like way above all these points. So I'm going to kind of shoot, if we shoot for the middle there, or kind of maybe shoot for the middle here. Okay, it's not an exact science. I don't know, let's shoot for the middle. Try to get as close to as many points as possible. So what do we think a good correlation coefficient of this is? All of these points are actually pretty close to those lines. This point's on the line, this point's almost on the line, this one's almost on, and all of them are pretty close. So it's going to be a negative. So the correlation coefficient is this guy's going to be negative. It's going to be negative something. But I think it might be pretty close to -1. So let's go 0.9, maybe, approximately. Again, this is just us guessing on what we think it might be. Based on your answer, what advice would you give someone selling hot cocoa? Make sure you have more of it on cold days. Because when it is cold, as the temp goes down, the number of hot, make sure you have more cocoa on cold days because it looks like that's the data trend.